What's up, folks? Welcome to Math Walkthroughs with Mr. Weeb. Today we are doing the practice section of Lesson 1 in our Patterns and Relations unit. Let's have a look at our first question. It says continue each pattern with the next two numbers. Okay, so here we see 7 to 14, then to 8, then to 16, then to 10, then 20, then to 14. All right, well, let's see. When I'm thinking about it, I'm thinking, okay, it's not a growing pattern because it's not going up every time. So from here to here, it looks like we are adding 7. From here to here, it looks like we're taking away 6. Then we're adding 8. Then from here to here, then we're taking away 6. Then we're adding 10. Then taking away 6. I don't see the pattern just yet. But. So that first one didn't work, but if I look at it again, I can see where it is. So the first step looks like we're doubling it, right? From here to here, we're multiplying by 2, then taking 6 away. This is doubled again, taking 6 away. Doubling it, and then taking away 6. So our next step to go from here to here would be to double it. So I think that it's 28, and then we would take away 6. Right, so here we multiplied by 2, and we take away 6, following our rules, and we'll get to 22. There it is. All right, our next one looks like it is increasing pattern. So let's add 2 from one step to the next. Then we're adding 3. Then we're adding 4. Then we're adding 5. Then we are adding 6. And adding 7. So from here to here, we should be adding 8, which would get us to 46. Then we're adding 9, which would get us to 55. All right, now we're using this pattern below right here for questions 3 to 5. So it says, what are the next two terms in the sequence? Okay, well, we've done questions like that before. This looks like another growing pattern. It looks like from here to here, we're adding 5. From here to here, we're again adding 5. Oh, I think I've deduced the pattern here. We're adding 5, always. So from here to here, we're going to add 5 again. And so 5 plus 23 is 28. And another 5 is going to be 33. Then it asks, what would the 20th term be in this sequence? Okay, well, we could just keep adding 5 20 times, or actually only 19 times, right? But I think that we can do it a little bit easier than that. Let's have a look at if we put this in a table of values where we have our term number here and we have our term value here. And we've got a long list here where we have, here's 1, here's 2, here's 3, here's 4, and then we skip a few and we say, here's 20. All right, I'm just going to move this down a little bit. Okay, our first value was 3, then 8, then 13, then 18, and so on. Let's have a look at the fourth term where the value is 18. Now, in order to get to 18, we've had to add 5 a number of times. We added 5 in the first step, we added 5 to get from the second term to the third term, and we added another 5 to get there. So how many 5s have we added to get up to 18? Well, we've got 3 groups of 5 here, right? So we've got 3 groups of 5, which got us to 15, but that doesn't make 18. We have to remember that we also have that first term. We have to add on that first term, which is adding on another 3. That gets us up to 18. Let's see if this same thing works in this case, in the third term. Okay, if we look at this, how many groups of 5 do we have that make up that third term? Well, you can see that we've added 5 twice. That's 2 groups of 5. So that's 2 groups of 5 plus that 3 that we started with. 2 groups of 5 is 10, plus 3 is 13. And if we look at it one more time, if we look here at the second term, we've only added 1 group of 5, so that's 1 group of 5 plus the 3 that we started with. 5 plus 3 is 8. It works for each of these cases. So if it works for each of these cases, we can assume that it's also going to work for our 20th case. We're going to have to add a lot more groups of 5 to get there, right? If we look at all of the cases, if we look at all of these cases, each one will have added a 5. So by the 20th term, we will have added 5 19 times, all the way up. So we can say that it's 19 groups of 5 plus 3. This is a much more efficient way to do things, because now if I wanted to find the 120th sequence, I could do it very easily without doing a table of values to get all the way there. All right, so if I can do this in my head because 19 is very, very close to 20, which is a landmark friendly number. And I can do 5 groups of 20 in my head. I could even count if I needed to. I could go 20, 40, 60, 80, 100. But I don't have 100. I only have, I have 1 group of 5 less than that. Because I don't have 20 groups of 5, I have 19. So that's 1 group of 5 less than 100. 100 take away 5 is 95 plus 3, which is 98. And that is your answer here. Let's have a look at the next question. It says, and again we're using the pattern below for questions 6 to 8, 6, 13, 20, 27. What are the next 2 terms in the sequence? Let's have a look. To get from here to here, it looks like I'm adding 7. And here to here, I'm adding 7. Okay, I think we've found our pattern. All right, what are the next 2 terms in the sequence? Well, if I add 7 to 27, I'll get 34. And if I add 7 again, I've got 41. All right, what would the 15th term be in this sequence? I think I will make another table of values where here we have our term number and our term value here. You'll notice I'm making it a vertical one rather than a horizontal. You can do it either way. So our term number here, 1, 2, 3, 4, and let's have our ... 15th value here. Okay, the first 4 were 6, 13, 20, 27. 6, 13, 20, 27. And each time we're adding 7 to get to the next stage. Let's see if we can find this rule this way. If we have a look at the 4th stage, for instance, we can see how many times have we added 7. We've got 3 groups of 7, but that's not going to do it. We've got 3 groups of 7, which will get us to 21, but we can't forget to add what we had at the beginning, which is 6. Will that get us there? Yeah, it will. 3 plus 7 is 21, plus 6 is 27. It works. Let's have a look, just to prove it to ourselves, let's have a look at the third one as well. By that point, we will have added 7 twice. We've got 2 groups of 7. So we'd write 2 groups of 7 plus the 6 that we started with. 2 times 7 is 14, plus 6 is 20. It works. Okay, last one. Let's just do this one too, just to make sure that it's working. We can see that we've got one group of 7. One group of 7 plus 6. 1 times 7 is 7, plus 6 is 13. It is definitely working. So, for our 15th case, what would we need? We would need 14 groups. 14 groups of 7 plus 6. And 14 times 7 is 98, plus 6 is 104. And that is our answer here. Let's move to the next page. All right. It says, look for a pattern. Give the rule for the table that tells the relationship between x and y. Okay, so we have to look, okay, here's x, here's y, here's x, here's y. And luckily, we don't have to discover it for ourselves. It gives us a few options. Is it A, multiply x by 10 to get to y? Well, let's try that out. When we multiply x times 10, well, that would give us 20. If we multiplied x by 10, here that would give us 40. This would give us 60. And you can tell that this is not 20. 4 times 10, this does not give us 40. So that's not the right one. So let's go ahead and have a look at the second one and see if that makes sense. Multiply x by 2, then subtract 1. Okay. If we went 2 times 2, subtract 1, that would be 4, take away 1 is 3. In the first case, does that get us to where we want to be? No, it doesn't. It doesn't give us our y. This isn't 3, this is 10. So already we know we don't have to keep going with that because it doesn't work. All right, let's move on and go ahead and look at C. If we multiply x by 3, then add 4. Let's try it out. 2 multiplied by 3, then add 4. That would give us 2 times 3, which is 6, plus 4 is 10. Okay, it works for that one, but don't stop there. Let's make sure that it works for the second case. Okay, if we have 4 as an x, and we multiply by 3 and add 4, 4 times 3 is 12, plus 4 is 16. It's looking like it's working. Let's try 9. Okay, if we have 9 and we multiply it by 3 and then add 4, what have we got? 9 times 3 is 27, plus 4 is 31. That one works. So this is the correct answer. Multiply by 3, then add 4. Let's look at number 8, which says, look for a pattern. Give the rule for the table that tells the relationship between A and B. Okay, again, we're doing the same thing. Here's A, here's B. Is there a rule that we can find? B equals A minus 2. Okay, does B, if we substitute 2 here and 1 here, does it work out? Let's find out. 2 equals, and instead of A, I'll put 1 minus 2. Is that right? No, 1 minus 2, it does not give us 2. So that's not right. If we substitute in the first case, here, where B is 2, equals A, which is 1, minus 1. 1 minus 1 is 0. So that one doesn't work either. Let's have a look at C. If B is 2, and here we have 2 times A, which is 1. 2 times 1, well, that does equal 2. So that one's right. But let's check the other ones just to make sure. If B is 2, or sorry, if B is 4 and A is 2, how does this work out? If B is 4 equals 2 times 2. That does equal 4. So that works. Let's skip right down to the fifth case. Okay, if b is 10 equals 2 times a, that works too. So this must be the correct answer. All right. Next, we have if the bells at Texas Middle School ring at 7:55, 8:40, 9:25, 10:10, explain how you can find when the next bell will ring. This is just a case of us finding this pattern and seeing what it is. So to go from here to here, well, let's see, 7:55, add on 5 minutes to get to 8 o'clock, and then 40 minutes. Well, 5 minutes and 40 minutes is going to be plus 45 minutes. Going from here to here, okay, I need to add 20 minutes to get to 9, and then another 25. 20 and 25 is another 45 minutes. It looks like we've found the pattern. Okay, the question though is, how can you find when the next bell will ring? Always add 45 minutes. I should also probably mention when the next bell would go. So I could add on the next bell will ring at, okay, adding on 45 to 10 would be 10:55. There we go. Let's move on to the next page. Okay. This is following number pattern rules. So if it says start at 63 and subtract 4 each time, all we're going to do is we're going to start at 63 and subtract 4. So we'll go 59, 55, 51, 47, and if you want to check all of the answers for this one, just check it on the OneNote. Let's move to the next page. Okay, this is another multiple choice where we're determining, it says determine what rule the function machine is using. So we've got some input going in here, and the machine is giving us some output over here. So from 24, it's going to 31. What's our rule? It looks like we're increasing each time from 35 to 42, 43 to 50. It looks like from 24 to 30 would be 6, and one more would be 7. My tens partner for 3 is a 7, so again, adding 7 would give us this. Adding 7 would give us this, so it looks like we are constantly just adding 7. All right, we did it. Next one. From here, the input is 12, and what we're getting is 25. It looks like we're always getting a bigger number in the output than in the input. But how much bigger? Well, it looks like I'll start here and see, because this is a friendly landmark number, and then I can know that, okay, 20 plus 10 is 30, and then 3 more is 33. So 10 and 3 is 13. If I add 13 to here, will I get 25? Yes, I will. If I add 13 to here, that works again. So it looks like we are adding 13 every time. In the next case, it looks like here to here we are getting smaller, and here we're getting smaller. Each case is getting smaller, but again, by how much? From 27 to 17 would be 10, but one less than that, we didn't jump that far. We only jumped 9 down. Here too, it looks like we jumped 9 down, so it looks like we are subtracting by 9. We're subtracting 9 every time. Okay, let's go to this one, where we are going 19 down to 12. 24 down to 17, 25 down to 18. We're subtracting every time, but how much? Are we subtracting 7 or are we subtracting 9? It looks to me 19 take away 7 would be 12. 24 take away 7 would be 17. So it looks like we are subtracting 7 every time. The next one looks like, again, we are subtracting. And 3 of the cases here are subtraction. But again, which one? 6, 5, or 4? Let's see. To get from 17 to 12, looks like we're taking away 5. Taking away 5, taking away 5. Looks like subtracting 5 is the way to go. And again, let's see, this is a decreasing number pattern because I can tell we're going down. This is our input, this is our output, and how much are we going down by? Is it 3, 7, or 4? Well, let's see. What's an easy one to do? Well, let's look at this one. From 53 to 50 would be a jump down of 3, and another one would give us 4. Subtracting 4 here, subtracting 4 every time. Let's do the next one. Going from here to here, we are increasing again, so we have to add, but how much? Well, let's see. It looks like from 29 to 30 is 1, 30 to 40 is 10, and then another 1. So that is 12. 10 plus 1 plus 1. So we are adding 12 every time. If we add 12 to this, does it make sense? Yeah, it looks like we're adding 12. Let's move on. Is it a growing pattern? Is it a shrinking pattern? It looks like it's shrinking. We're going down each time. So, but by how much? What's our rule? Every time we are going down by how much? From 32 to 22 would be 10, but 2 less than that would be 8. So it looks like we're subtracting 8. And yes, it does make sense because here's 58, here's 50. Yes, we went down by 8. And our last one on this page, now we are looking like we're increasing again. 13 plus 7 would be 20. 23 plus 7 would be 30. So we are adding 7. Oops, adding 7. And don't forget on this page to write your answers. Write your answers over here. Thanks for watching.